Hello students, let's try to understand the displacement reaction. Student, we are going to understand displacement reaction. In a displacement reaction, an ion or an atom in a compound is replaced by an ion or an atom of another element. It may be denoted as so x plus y z. X plus yz, what it will give student xz plus y. So it is going to displace, x is displacing the y. Okay, displacement reaction fit into two categories: metal displacement and non-metal displacement reaction. So firstly we are going to understand that is metal displacement reaction. Student, a metal in a compound can be displaced by another metal in the uncombined state. We have already discussed about this case of the reaction under the section 821. Okay, metal displacement reaction find many application in metallurgical process in which pure metal are obtained from their compound in ores. A few such examples are, what is there student? Copper sulfate are there. It is if you are treating with the zinc, so zinc will displace the copper, so it will give copper and copper sulfate, zinc sulfate. So here see, zinc is 0 to plus 1, that is what oxidation, and copper is plus 2 to 0, that is what is, this is the reduction. So both the process are happening. You see here student, this case V2O5, there is plus 5 to 0, plus 5 to 0, that is reduction, and 0 to plus 2, that is oxidation. So vanadium pentoxide on reaction with calcium, it will give vanadium and calcium oxide. Okay, here you see titanium tetrachloride react with magnesium, it is giving titanium and that is magnesium chloride. So here is what is there student, plus 4. What about here is 0, so this is plus 4 to 0 reduction, and here is plus 2. So 0 to plus 2, what is that, is oxidation. If you talk about the chromic oxide, so what is there, here is the plus 3, here is 0, plus 3 to 0, plus 3 to 0, it means reduction, and here you see 0 to plus 3, this is what is oxidation. So these two are happening. In each case the reducing metal is a better reducing agent than the one that is the being reduced, which evenly show more capability to lose electron as compared to the one that is reduced. It means in the general terms, that is whichever the displacing the student, that is the more reactive metals are getting displaced. Okay, if you see, that is what the reactivity order, like that potassium is there student, then sodium is there, then calcium is there, then magnesium is there, then iron is there, zinc is there. Okay, then suppose here is also aluminum is also there student, and finally that is hydrogen is there, right? Below also, that is Hg is there, then copper is there, Ag is there, Au is there, and Pt are there. So reactivity series, all the above metal like sodium can displace the salt solution of potassium can displace the salt solution of sodium, calcium, magnesium, aluminum, iron, zinc, etc. So that is what the reactivity series is doing. Whatever they are upside, they will displace the metal present downside from their salt solution. They do not participate in such kind of silver, gold, platinum do not participate. This is very less reactive, so it it's salt, it can be displaced by any of the metal like that potassium, sodium, calcium, magnesium, this all are the example. Now let us have a non-metal displacement reaction. If you see non-metal displacement, the non-metal displacement redox reaction include hydrogen displacement and a rarely occurring reaction involving oxygen displacement. They are saying a non-metal displacement redox reaction include hydrogen displacement or a rarely occurring reaction involving oxygen displacement. So have a look here, what is there? All alkali metals and some alkaline earth metal, calcium, strontium, barium, which are very good reductant, will displace the hydrogen from the cold water. So there sodium, if you are treating with the cold water, this is the cold water, so NaOH, and this is displacing the hydrogen gas. So this has become the non-metal displacement. Calcium plus water, it will see calcium hydroxide, it will displace the hydrogen gas. Again non-metal is getting displaced. Less active metals such as magnesium and iron react with steam to produce dihydrogen gas. Okay, like Mg plus water, magnesium hydroxide, it is giving hydrogen gas. Iron plus calcium water, it will give, that is iron oxide plus hydrogen gas. Many metals, including those which do not react with cold water, are capable to displacing hydrogen from acid. Dihydrogen from acid may even be produced by such metal which do not react with steam. Okay, see student, what the point here, they are saying dihydrogen from acid may even be produced by such metal which do not react with steam. Like cadmium and tin are the example of such metal. A few examples for displacement of the hydrogen from acid are what there: zinc plus HCl, ZnCl2 plus hydrogen gas; Mg plus HCl, MgCl2 plus hydrogen gas; Fe plus 2HCl, FeCl2 plus hydrogen gas. So what is that? Is non-metal displacement. Reaction 8.37 and 8.39 are used to prepare the dihydrogen gas in the laboratory. So 8.37, this one is there. Okay, and another is there 8.38 and 8. They are used to prepare the hydrogen gas in the laboratory. Here the reactivity of metal is reflected in the rate of hydrogen gas evolution, which is the slowest for the least active metal Fe and the fastest for the most active metal Mg. What the point here, see what the point here they are saying, student, the reactivity of metal to reflect in the rate of hydrogen gas evolution, which is the slowest for the least active metal Fe and the fastest for the most active metal Mg. Very less active metal which may occurs in the native state, such as the silver, gold, do not react even with the hydrochloric acid. Okay, in section 8.21 we have already discussed that the metal like zinc, copper and silver through tendency to lose electron, so they are reducing activity. In order, zinc, copper, Ag, like metal activity series also exist for the halogen. The power of these elements as an oxidizing agent decreases as we move down from the fluorine to iodine in group 17 of the periodic table. Okay, so if you are moving down the group, the reactivity is increasing. This implies that fluorine is so reactive that it can replace the chlorine, bromine and iodine. Means down the group reactivity is decreasing. Let us have again group. Okay, like metal, active metal series also exists for halogen. The power of these element as oxidizing agent decreases as we move down the group from fluorine to iodine group. Okay, group 17. They are saying this implies that fluorine is so reactive that it can displace the chlorine, bromine and iodine ion in the solution. In fact, fluorine is so reactive that it attacks water and displaces the oxygen of water. What is there? Water plus 2F2, it will give, that is 4HF plus O2. It is for this reason that the displacement reaction of the chlorine, bromine and iodine using fluorine are not generally carried out in an aqueous solution. On the other hand, chlorine can displace bromine and iodine ion in aqueous solution as shown below. So chlorine, if you are treating with the KBr, so it will give Cl and Br2. Cl2 plus Ki, it is giving KCl plus I2. So that is what is, that is here is Br is displacing and I is displacing. AgPr2 and I2 are the colored and dissolve in CCl4, can easily be identified from the color of the solution. The above reaction can be written in ionic form. See, Cl2 plus 2Br minus, it will give 2Cl minus and Br2. So it is getting displaced. Cl2 plus 2I minus Cl, 2Cl minus and I2. Okay. Here you see reaction 8.41 and 8.42 from the basis of identifying. So Br negative and I minus, Br negative and I minus in the laboratory through the test popularly known as layer test. So if you are talking about Br minus and I minus in the laboratory through the test popularly known as layer test, it may not be out of the place to mention here that bromine likewise can be displaced iodine or iodide ion in the solution. Let us have a look over. So Br2 is there, it is 2I minus, so it will give 2 Br minus and I2. The halogen displacement reaction have a direct industrial application. What they are saying, the halogen displacement reaction have a direct industrial application. The recovery of halogen from their halide require an oxidation process which is represented by 2x minus, it will give x2 plus 2 electron. Here x denote halogen element where chemical means are available to oxidized Cl minus, Br minus, I minus as a fluorine in the strongest oxidizing agent. Here you see there is no way to convert F minus ion to F2 by chemical means. The only way to achieve F2 from F minus is to oxidize electrolytically, the detail of which you will study at a later stage. So that is what the all about, student. That is displacement reaction. I hope it will be little bit easy. If you want to understand that is metal displacement or non-metal displacement, let us have the metal displacement. Like copper sulfate is there, student. If you are treating with the iron, so it will give simply, it will give that is FeSO4 and it will give the copper. Or even you are having copper sulfate and you are treating with the zinc, student, so what it will give, going to give ZnSO4 plus what it will give, that is copper. These are the point. Non-metal displacement means like Zn is there and if you are treating that is 2HCl, so what it will going to give, it will give going to give ZnCl2 plus hydrogen gas. So this is going to be a non-metal displacement. Okay, if you are having zinc plus if you are treating with the H2SO4, so what it is going to get you, student, that is it is going to give ZnSO4 and it is going to give hydrogen gas. So it is all about the metal and non-metal displacement reaction, student. I hope it will be you will be able to understand in detail. Okay, thank you, students.